Welcome, Matt Taylor here with a video on how to do the question 4 in exercise 1.3. So the question asks, state the range of the following functions using your CAS to see the graphs. So doing question A, there's the first function there. So I'll switch over to the CAS. This is what the graph looks like. So we can see easily that the range will go, which is the y values, goes from here further down, so you can just go graph trace, get the maximum there. We see it goes from -1, and there's no reason for it to not continue down forever, so it's just going to keep going down forever. So it's -1 to infinity, and that is including -1 and excluding infinity. So if we switch over here, I'll show you how I graphed that. So I basically use this function where defined fx, and if you use this button here on this calculator, this model of the calculator, you can click on this button. You want one piece for the function, and then in this you can write in your equation, like x squared plus 5x for example, and then in here you can write your restriction, like x is less than 0. So that's sort of like an example of an equation you can write using that, but obviously you can just put in, that's what it asks in the question, so you put it in there, but that's how you write an equation like that. When you use the define variable, you have to put a space, not a bracket or anything like with other commands. You have to put a space and then any letter, so it can be like G or X or whatever, but it doesn't really matter. Normally go F. It's bold X, I've already defined F, but that doesn't matter. Then you put a bracket and the variable you're going to use. So yeah, and then once you're done, you just tab and write in f of x, and that will come up with the graph. So that's how you do 4a. We'll do the next question here. So y equals 4 take x cubed take 1. So basically I want to define it. I think that was it, I'll check. Yep, and x is equal to or greater than 0. Okay. Sorry. I just explained how to do that and I got it wrong. That's embarrassing. But anyway, since I used the same variable, it automatically graphed it for me. So if we move up here, we can see that it's going on for a long time. I'm just going to click over here, if it ever lets me, and then zoom out. You can use the fit, so you can, it's not always very useful because look at that, that's really big, but you can basically use it to get the part of the graph you actually want to see, and then do stuff like this. So we can see the range, or it doesn't go up forever like it did on the last graph. If we trace that intercept there, you can see it goes up to 63, and then it's going to go down forever. So you basically, the range will be 63, including 63 to infinity. Next one, I'm just doing A, C, and E, by the way. A third, x take 3 to the power of 4 plus 2. So we're going to define it again. Okay, now when I switch over to the graph, it will have already drawn. I'm going to go back to the standard quadrants, but you can't see that, so I'll just have to go fit again. See, I think this is the best way to do it if you don't know what points the graph is actually going to go through. So you can see here we've got the bottom of the graph starts off here, and it just keeps going up from there, so it's going to be, don't think we have a y-intercept. No, we don't. We don't have a y-intercept because the restriction was less than x. It can't be, x was less than 0, so it couldn't be 0 exactly. So the range will be 29.1, but not including 29.1, so a round bracket to positive infinity. So that's how to do question 4. Hope that helps. Thanks for watching. See you in another video.